Imagine looking down at the earth from a slow, drifting height, where rivers become silver threads and forests become soft green felt. Before we go any further, if you want a brand new Earth topic every single night to fall asleep to, subscribe. One tap and a new story is waiting for you every evening. From up here, the planet looks calm and quiet, smoothed by distance into a single rounded shape. But if you lower yourself closer, drifting down through the clouds, something curious begins to appear. The ground is not as random as you might expect. In the dry red sand of the Namib desert, small bare circles stand evenly spaced, like polka dots stretched across a vast blanket. In the cracked floor of an old American lakebed, heavy stones sit at the end of long, winding trails carved into the clay. On lonely mountainsides, stones gather themselves into stripes. In the deep cold of the Arctic, the soil sorts itself into honeycombs of pebble and silt. On the basalt coast of Northern Ireland, columns of dark rock rise in tight hexagons, fitted together like a tiled floor laid by no hand we know. These are some of the quiet puzzles written on the ground. They are not loud. They do not move quickly. Most of them have been sitting there for centuries, waiting patiently for someone to notice. And when we do notice, the same question rises up out of the soil again and again. Why does nature, which we so often picture as wild and disorderly, keep producing such careful patterns? It is a strange thing to sit with. We expect the world to be messy. We expect rivers to wander, winds to scatter, deserts to be blank. And often they are. But every so often, the surface of the earth seems to settle into a kind of geometry. Circles appear at even spacings. Polygons knit themselves together in mud. Stones line up in rows along slopes. Bare patches form in grass with the regularity of dots on graph paper. For each of these patterns, scientists have theories, sometimes 2 theories, sometimes more. In the Namib, one group of researchers argues that termites beneath the sand are quietly engineering the circles by feeding on roots in a precise, repeating way. Another group argues that the circles form on their own through the simple competition of plants reaching for the same scarce water. Both ideas have evidence behind them. Neither has fully won the long, slow argument. The bare red dots remain on the ground, and the question remains open. On Racetrack, Playa, in a dry corner of California, heavy stones have left long trails behind them, as though they had wandered across the flat ground in the night. For decades, no one had seen them move. People offered explanations of wind, of ice, of slick mud, of strange forces. Eventually, careful watchers caught them in the act, drifting along on thin sheets of ice during rare, wet winters. And yet, even with that answer in hand, smaller questions still linger. Why some stones and not others? Why some trails curve and others run straight? Why a pattern again where we did not expect one? These are the kinds of puzzles we will sit with tonight. None of them are urgent. None of them are frightening. They are simply curious. They are the kind of mysteries that reward slow thinking, the kind that fit comfortably into the soft hours before sleep. We will travel from the deserts of southern Africa to the salt flats of Death Valley, from the mounded prairies of the Pacific Northwest to the cracked polygons of the high Arctic. We will walk along the basalt steps of a cold northern coast. We will look at sand ripples shaped by wind and ice rounds floating on slow winter rivers. Along the way, we will meet competing ideas. Some scientists believe these patterns are signs of living things organizing the ground. Others believe the ground organizes itself through physics alone, with no living help at all. The truth, in many cases, may be a quiet blend of the two, or it may be something else entirely, something we have not yet learned how to see. For now, what matters is the gentle wonder of it. The fact that our planet, in countless quiet corners, keeps drawing shapes we cannot fully explain. The patterns are there whether we watch them or not. They have been there long before us, and they will likely be there long after. So let your eyes soften. Let the room grow still, and let us drift slowly down toward the quiet puzzles written on the ground. Picture a stretch of dry grassland on the edge of the Namib Desert in the southwest of Africa. The grass is pale gold, brushed thin by the wind, growing in a low fuzz across the sand. The soil beneath it is the color of old brick, a soft, rusty red that holds the morning light. And scattered across this gentle gold and red plain, as far as the eye can see, are round bare patches of bare earth. Each one is a near-perfect circle. These are the fairy circles of Namibia. From the ground, they look like quiet, bald spots in the grass. From the air, they look like polka dots painted across the desert by a careful, patient hand. They run in soft lines along the dry plains for hundreds of miles, from southern Angola down through Namibia and into the edge of South Africa. No one planted them. No one carved them. They simply appear. Each circle is roughly the size of a small backyard pool. The smallest are about 2 meters across, which is about the length of a tall person lying down. The largest can stretch to 15 meters, wider than a city bus is long. Most settle somewhere in the middle, around 4 to 7 meters across. Inside the ring, the soil is bare and slightly sunken. Around the edge, the grass grows taller and greener than the grass anywhere else on the plain, forming a thick, living rim. The spacing between the circles is what makes them feel so strange. They do not clump together. They do not drift apart. They sit at quiet, even distances from one another, like seats arranged in a vast outdoor theater. If you stand inside one and look around, the next circle is roughly the same distance away in every direction. Researchers who have mapped them from the sky describe the pattern as almost crystal-like. Yet the ground itself is not crystal. It is loose sand and dry grass and a few patient insects. The land here is harsh and beautiful. Rain falls only a handful of times a year, sometimes less. The air is dry enough to crack lips within minutes. Summer temperatures climb above 40 degrees Celsius, which is around the temperature of a hot bath. At night, the desert can grow surprisingly cool, and the cleared circles seem to breathe out a faint warmth they collected from the sun. The grass that grows around them is mostly a tough species called Stipagrostes, a slender bunch grass that can survive on almost nothing. No one knows exactly how old any single circle is. Some studies suggest individual circles can live for 30 to 60 years before slowly closing up and disappearing. New ones open elsewhere on the plain, as if the pattern itself is alive and shifting. Across a human lifetime, a person might watch one circle quietly fade while another opens nearby. The overall pattern, though, has been there for as long as anyone can remember. Local communities have known about these markings for many generations, long before satellites looked down on them. For a long time, almost no one outside the region had heard of them. The Namib is remote, the roads are few, and the circles do not reveal their full shape unless you climb high above them. Only in the last few decades, as small aircraft and then satellites began passing overhead, did the wider world start to see the dotted pattern stretching across the plains. The images stopped scientists in their tracks. Something out there, in one of the driest places on Earth, was drawing perfect circles in the sand. In the simplest terms, a fairy circle is a round bare patch in arid grassland, ringed by taller grass, arranged at strangely regular distances from its neighbors, with no fence, no hand, and no obvious cause. That is all we can say with confidence. Everything beyond that, every theory of why they form, and why they space themselves so evenly, is still being argued and tested today. When the wind moves across the plain at dusk, the tall rim grasses sway in soft waves. The bare red soil inside each circle catches the last orange light. Long shadows stretch from the rims toward the next circle, and the next, and the next, like a slow handshake reaching across the desert. It is a calm, patient landscape. There is nothing frightening about it, only a quiet question lying out in the open under the sky. In the next section, we will travel far from this red desert to a flat, cracked lake bed in California, where stones the size of melons appear to slide across the ground on their own, leaving long trails behind them. Another quiet pattern, another open question. Far from the red sands of the Namib, in a quiet corner of California's Death Valley, there lies a dry lake bed called Racetrack Playa. It is flat and pale, cracked into 1,000 small tiles of dried mud. The mountains around it rise in soft brown folds. The wind moves across it almost without sound, and scattered across this empty plain are stones. Some are small, no bigger than a fist. Others weigh as much as a person. Behind each stone, etched into the dry mud, runs a long trail. The trails curve. They turn. Some run straight for hundreds of feet, then bend sharply, as if the stone changed its mind. Some trails travel side by side, perfectly parallel, as if two stones had decided to walk together. Others cross. Others spin in long, lazy loops. The stones sit at the end of these trails, quiet and still, looking exactly like ordinary rocks. There is no sign of any hand that pushed them. No tire tracks. No footprints. Only the stone, the trail, and the silent sky above. For most of the 20th century, no one had ever seen the stones move. Visitors would arrive, photograph the trails, walk the playa, and leave. The stones would sit there as if they had always sat there. Yet the trails were fresh. The mud held the marks clearly. Something was moving these rocks across the desert floor when no one was watching. The story of how these trails came to exist is, in a way, the story of how a very particular set of conditions had to fall into place. The playa itself was born from an old lake. Long ago, water filled this basin between the mountains. Over thousands of years, the climate dried. The lake shrank. What remained was a flat bed of fine sediment, polished smooth by the slow retreat of water. The surface became almost level, almost perfectly horizontal across 2 miles of desert. The stones came from the cliffs at the playa's edge. Over countless seasons, pieces of rock broke loose from those slopes and tumbled down. They came to rest on the flat playa floor. There they stayed, slowly weathering, slowly waiting. For the trails to begin, the desert needed a rare combination of weather. Rain had to fall, but not too much. The playa had to flood, but only with a thin sheet of water, no more than a few inches deep. The night air had to drop below freezing, but only just. The wind had to come at the right hour, with the right strength. All of these things together in one quiet window of time. For decades, researchers offered different ideas about what might be happening. Some thought strong winds alone pushed the stones across slick, wet mud. Others thought thick sheets of ice formed around the stones in winter, and the wind dragged the ice like a sail, pulling the stones with it. Some wondered if the Playa surface became so slippery after rain that even a gentle breeze could nudge a heavy rock into motion. Each idea seemed possible. None had been proven. Then, in the early years of the 21st century, researchers placed small instruments on a few of the stones and waited. They returned, season after season. And finally, on a cold winter day, they witnessed the movement. What they saw was stranger and gentler than anyone had guessed. After a shallow flood, a thin pane of ice had formed across the Playa overnight. In the morning sun, the ice began to break into wide, floating sheets. A light breeze came across the water. The drifting ice sheets pressed against the stones, and the stones, sitting in soft mud beneath the shallow water, slid forward at the pace of a slow walk. They moved only a few inches per second. They moved silently. They moved without drama. Then the wind shifted and they stopped. So the origin of the trails, at least at Racetrack Playa, may now be partly understood. Yet questions remain. Not every sailing stone field on Earth has been observed this way. Other dry lake beds in other deserts also show moving stones, and the conditions there are not always the same. Some trails are far longer than the recent observations can fully explain. Some stones leave trails that suggest motion no ice sheet could easily produce. The puzzle, in other words, has cracked open just a little. The desert has whispered a part of its answer, but it has not given the whole story. And the deeper question, the one that joins these stones to the circles and the polygons and the mounds, still waits beneath the quiet surface of the dry lake. To understand why the stones at Racetrack Playa leave their long, curling trails across the desert floor, it helps to walk slowly through the things the Playa is actually made of. The ground itself is a dry lake bed, flat almost beyond belief, stretching nearly 3 miles from end to end. The surface is cracked into soft hexagons of pale clay. That clay is mostly very fine silt and mud, washed down from the surrounding mountains over many thousands of years. Each rainstorm carried a thin layer of sediment to the basin floor, and each dry season baked it hard. Over time, layer pressed against layer, until the Playa became this smooth. even canvas on which the stones could write their slow stories. The stones themselves are pieces of dolomite and syenite. Dolomite is a pale rock made of calcium and magnesium and carbon and oxygen, all bonded together in tight crystal shapes. Syenite is a darker rock, rich in feldspar, a mineral that gives much of the world's granite its rosy or grayish glow. These stones did not grow on the Playa. They tumbled down from the steep cliffs at the southern edge of the basin, broken loose by frost and gravity over long stretches of time. They came to rest on the flat clay where the trails begin. Look closer, and the building blocks of these rocks go further back than any desert. The calcium inside the dolomite was once locked into ancient seashells. When this part of California sat beneath a warm shallow sea hundreds of millions of years ago, the magnesium drifted up from older volcanic rock, weathered down by rain into the slow chemistry of the seafloor. The iron streaked through the syenite was forged inside long-dead stars, in furnaces so hot that lighter atoms fused into heavier ones. When those stars ended their lives and scattered their material into space, some of that iron eventually settled into the cloud of dust that became our planet. Every stone on the Playa carries a quiet trace of that older story. The clay holds its own histories. The fine particles are mostly silicates, built from silicon and oxygen, the two most common elements in Earth's crust. Mixed into the silt are tiny grains of quartz mica and the patient remains of plants and microbes that once lived in shallower water. When rain falls, the clay drinks it in and softens. When the sun returns, the water leaves and the surface dries into those familiar polygons. It is on this thin film of softened clay that the stones seem to slide, though the exact recipe of conditions remained a puzzle for many decades. Above the Playa floats the air, and the air matters too. The atmosphere is mostly nitrogen and oxygen, with small amounts of argon, carbon dioxide, and water vapor. The oxygen we breathe was placed there by ancient microbes billions of years ago, in one of the great quiet revolutions in Earth's history. Some researchers think much of our water arrived on icy comets and damp asteroids in the planet's early days. Other researchers suggest the water was already mixed into the dust that built Earth from the beginning. The answer is not yet settled. Whichever story is true, the moisture that occasionally pools on Racetrack Playa is a guest from very far away and very long ago, when that water freezes on cold winter nights. It forms thin sheets of ice across the puddles. Ice is simply water arranged in a crystal pattern, each molecule holding hands with the next at gentle angles. One leading idea is that these thin ice sheets, pushed by light winds, nudge the stones across the slick clay in slow, silent journeys. A competing idea points to stronger gusts, or to slippery films of wet algae, or to some mix of all these things. The materials are known. The exact dance between them is still being worked out. So the trails behind the stones are written in a kind of cosmic ink. Iron from old stars, calcium from ancient seas, silica from broken mountains, water that may have ridden in on comets, ice formed from a few quiet nights of cold, wind shaped by the warming and cooling of a whole planet. All of it gathers on this one flat patch of desert and somehow arranges itself into a pattern that looks almost deliberate, almost drawn. The deeper question stays with us as we move on. The pieces are simple. The forces are familiar, yet the lines they leave behind, curving and parallel and oddly graceful, ask something the materials alone cannot answer. Why, out of all this scattered stardust and slow chemistry, does anything organized ever appear at all? Let us return now to the soft red plains of the Namib and to the rings of grass that grow there in such strange and patient order. We spoke before of the bare circles themselves, those round patches of bare earth scattered across the dunes like coins dropped from the sky. Now we turn to the green that surrounds them. For around each bare circle stands a ring of tall grass, taller and greener than the grass farther away. And that ring of grass is the heart of the puzzle. The grass is a clue. It tells us that something is moving beneath the surface. Something is pulling the water inward, or pushing the roots outward, or shaping the soil in ways we cannot see from above. The forces at work here are quiet ones. No volcano rumbles below. No river carves the land. The forces are softer than that, and slower and harder to name. Think first of water. In the Namib, rain is rare and precious. When it falls, it sinks quickly into the sandy soil. Some of it pools below the surface, held in the spaces between the grains. The grass on the edge of each circle reaches its roots inward, into that bare patch, drinking from a hidden well. The bare ground, with no plants growing on it, loses less water to the sky. So the bare circle becomes a small reservoir, and the ring of grass becomes its mouth. This is one idea, and it is a gentle one. Other forces may be at work too. Gravity pulls water downward through the sand, deeper than the shallow roots of small plants can reach. Heat from the desert sun bakes the surface, drawing moisture up again into the dry air. Between these two poles, a delicate balance forms. The bare circles may sit exactly where this balance tips one way, and the grass rings may grow exactly where it tips the other. The pattern is sculpted not by any single force, but by the quiet conversation between them. Pressure plays a part as well. The weight of the soil itself, pressing down over centuries, can shape how water moves through it. In some places, the sand is packed tight. In others, it is loose and crumbly. Water flows differently through each, and roots feel that difference. Where the soil is firm, the grass struggles. Where it is loose, the grass thrives. Over many years, these small differences may grow into the great rings we see today. There is another idea, and it brings small lives into the story. Some researchers wonder whether termites, living quietly beneath the soil, clear the bare patches by eating the roots of young plants. The termite colonies in this view would push outward in even spaces, each one defending its own patch of ground. The grass at the edges, fed by the moisture the bare patch holds, grows tall in response. The pattern would then come from the slow, steady work of many small jaws. Other researchers are not convinced. They point to places where no termites have been found and where the circles still appear. They argue that the rings form on their own, through the plants alone, as roots compete for water in dry soil. In this view, the grass is both the artist and the canvas. Each plant pulls water toward itself, and the strongest pullers win. And over time, the pattern settles into the shape we see. The forces here are biological, but they act like physics, like magnets arranging iron filings on a sheet of paper. Both ideas may be partly true. The desert is wide, and the rings appear in many places, and perhaps no single force shapes them all. Wind, sun, root, insect, grain of sand. Each one pushes a little. Each one pulls a little. Over decades, the land remembers every nudge, and the rings appear as the sum of all those quiet nudges added together. What is remarkable is how steady the pattern is. The bare circles are nearly the same size. The grass rings around them are nearly the same width. The spacing between neighboring circles is nearly the same distance. This is not the kind of order we expect from chaos. It looks designed, though no one has designed it. It looks planned, though no plan exists. The forces that shape it are invisible, but their fingerprints are everywhere on the ground. And so, the grass rings stand in their quiet geometry, drinking from hidden wells, marking the slow arithmetic of water and root and soil. We do not yet know which force matters most. We do not yet know whether one answer fits every desert. The question remains open, and the grass keeps growing, ring upon ring, under the wide and silent sky. Tonight, before we wander further, let us sit with the scale of these patterns, the size of them, the reach of them, because the fairy circles of the Namib desert are not a small curiosity tucked into one quiet valley. They are written across the land in numbers that are hard to hold in the mind all at once. Picture a strip of dry grassland that runs along the western edge of southern Africa. It begins in southern Angola, drifts down through Namibia, and reaches into the northern edge of South Africa. That strip is roughly 1,100 miles long. If you set it down across the United States, it would stretch from New York City to the middle of Iowa, and along nearly all of that length, in a narrow band, perhaps 100 miles wide, the circles appear. Millions of them. No one has counted each one. No one ever will. Each circle is itself a small thing. Most are between 7 and 40 feet across. Imagine a circle the size of a small backyard pool, or sometimes the size of a modest house. The bare patch inside is a soft reddish sand, often slightly sunken, ringed by a band of taller grass that leans inward like a quiet crowd. Walk among them on foot, and they feel intimate, almost shy. Rise up in a small plain, and the ground below turns into a vast field of polka dots that runs to the horizon and keeps going. The spacing is the part that troubles the mind. The circles are not scattered. They are placed. From above, they form a soft honeycomb, each circle keeping its distance from the next, as if every red dot were aware of its neighbors. The math of that spacing is so even that researchers can measure it. The average distance between centers stays steady across many miles, across different slopes, across changes in soil. Something, somewhere, is keeping the pattern tidy. Now hold that image in your mind and let us travel to the other side of the world, in the dry red interior of Western Australia, near the old mining town of Newman. Another field of circles waits. These were only confirmed by science in 2014. They look astonishingly like the Namibian ones. Bare red patches ringed by grass, spaced across the land in that same gentle honeycomb. But the grasses are different species. The soils are different. The climate is similar, but not identical. And the continents are separated by more than 6,000 miles of ocean, 2 deserts, 2 patterns, 1 shape. That is the puzzle of scale. Not just how many circles or how wide the band, but how the same design appears in 2 places that have never shared a single blade of grass. If you shrank the earth to the size of a basketball, those 2 patches of patterned ground would sit on opposite sides of the ball, separated by the curve of an entire ocean. Yet the spacing between circles, measured in meters, is roughly the same in both. This is where 2 theories meet, and neither has one. One idea says the circles are the work of small creatures in the soil. In Namibia, sand termites. In Australia, perhaps a different insect, or perhaps something else entirely. The other idea says the circles are made by the plants themselves, competing for scarce water, organizing into rings the way ripples organize on a pond. Both theories try to explain the spacing. Both theories try to explain why two deserts, oceans apart, would arrive at the same shape. Think for a moment of the time involved. A single fairy circle is not a quick thing. Researchers who have marked individual circles and watched them for decades find that they are slow. A circle may live for 30 years. Some may live for 60. A few, perhaps longer. They appear, they hold their shape, and they fade, all on a timescale closer to a human life than to a season. So the pattern you see from a small plane today is, in part, the pattern that was there when your grandparents were young. The land remembers. Multiply that by the size of the field, by the millions of circles, and the scale becomes almost gentle. This is not a sudden event. It is a slow, patient design, drawn across deserts older than any city, refreshed circle by circle, decade by decade, for as long as anyone has been looking. And still, when you stand in the middle of it, the question is simple and unanswered. Who or what is drawing the dots? And how do two faraway deserts agree on the same quiet geometry without ever having spoken? We do not know yet. We sit with it for now, and we wonder. Imagine for a quiet moment that you are walking out across the red earth of the Namib at the soft hour just after sunrise. The light is low and warm. Long shadows stretch from every pebble and every blade of grass. The air is cool, but you can already feel the desert preparing for the heat of the day. Beneath your boots, the sand makes a faint, dry sound, like old paper being turned in a library no one visits. You come to the edge of one of the fairy circles. It is wider than you expected. From the ground, the circle looks almost like a shallow dish pressed into the earth. The center is bare red sand, smooth and fine, with no grass at all. Around the rim, taller grasses lean inward, forming a soft, pale crown. The contrast is gentle but clear. Inside, nothing. Around the edge, a thicker ring of life than anywhere else on the plain. Kneel down for a moment. Run your fingers through the bare sand at the center. It feels cool just below the surface, cooler than the sand outside the circle. That small temperature difference is one of the quiet clues researchers keep returning to. The bare patch holds moisture differently. Water that falls during the rare desert rains seems to soak straight down through the loose grains, traveling deep into the soil where the grasses on the rim can drink it later. The circle in this view acts almost like a tiny reservoir hidden under your knees. Look closer. The sand is not as empty as it first appears. Tiny tracks cross the bare patch, the delicate, looping prints of a beetle, the faint trail of a small lizard, the brush stroke of a passing snake. Insects move in and out of grain-sized holes. Ants carry pale seeds. Somewhere beneath you, perhaps, there are termites in their cool, dark galleries, working on tunnels you will never see. Whether those termites are the architects of the circle or only its tenants is one of the long, open questions of this place. Stand up and look outward. The plain stretches away in every direction, and the circles stretch with it. Each one is its own quiet dish in the red ground. Each one is spaced almost evenly from its neighbors, as if some invisible hand had measured the gaps. From this low angle, you see them only as patches of paler sand against the grass. The pattern is hard to read from down here. The grass between the circles is short and golden, brittle in places, with tufts that sway when the wind moves through. The colors are softer than photographs suggest. The sand is not a bright red, but a warm, dusty orange, with shades of pink where the morning light catches it. The grass is pale straw and silver green. The sky above is a thin, washed blue. There are no clouds. The horizon is a long, flat line, broken here and there by low, distant hills that seem to float on a layer of heat haze even this early. Walk a little further, and you may notice something curious. The grasses on the rim of each circle are not random. They grow tallest and thickest right at the edge, then thin out as you move away. Beneath them, in the shaded soil, small creatures find shelter. Geckos rest under the cooler grass roots. Spiders build low webs between the stems. Tiny rodents tunnel along the ring, drawn to the moisture and the cover. The circle becomes a small island of life within a wider plane of life. A quiet concentration of activity organized around a bare center. What lies beneath the bare center remains partly hidden. Some researchers have dug down and described networks of fine roots reaching inward from the rim grasses, drinking the deep water stored there. Others have described chambers and channels left by sand termites busy below the surface. Both have been found in different circles, in different places. Which one truly shapes the pattern, and whether both might work together, remains an open question. The ground keeps its answer to itself. Stand a little longer. Listen. The wind moves across the plain with a low, steady whisper. A beetle ticks somewhere in the grass. The sun climbs another notch, and the shadows shorten. The circle at your feet looks the same as it did 1,000 years ago, probably, and likely the same as it will look long after you have walked away. What you see at the surface is only a small part of the puzzle. The rest is held quietly underground, in roots and grains and small living things, waiting to be understood. To stand on a patch of bare desert and look down at a fairy circle is to see only the top of something. The real story, many researchers believe, is happening below your feet, in the quiet dark of the soil, where water moves in ways we cannot easily watch. This is where the mystery deepens. The patterns on the surface may simply be the visible edge of a slow, hidden conversation between roots, sand, and rain. Picture the soil under a Namibian fairy circle in cross-section. Near the surface, the sand is pale and dry. A little deeper, it grows slightly darker, slightly cooler. Deeper still, in the shaded zone beneath the bare patch, something surprising happens. The soil holds more moisture than the soil under the surrounding grass. Rain that falls on the empty circle sinks straight down. There are no thirsty roots to drink it up, so the water keeps going, gathering quietly in the deeper layers, like a small hidden reservoir under a window of bare sand. The grass around the edge of the circle seems to know this. Its roots reach inward, sideways, drawn toward the buried water. From above, the ring of taller, greener grass around each bare patch looks almost decorative, like a soft green halo. From below, it looks like a crowd of slender straws, all sipping from the same shaded cup. This is one of the central ideas in what researchers call the self-organization theory. The plants are not arranging themselves on purpose. They are simply following the water. The competing idea, of course, is that termites are doing the arranging. In that picture, the colonies eat the roots inside each circle, creating the bare patch from below in a different way. The soil still holds extra water, but only because nothing is left to drink it. Both theories agree on the buried moisture. They disagree on who or what first cleared the ground above it. The deeper layers cannot tell us which story came first. They only show us the result. Water shapes hidden patterns in many other places too. Beneath the salt flats of Death Valley, thin sheets of brine rise and sink through the crust in slow loops. Salty water near the surface grows heavy as it dries. It sinks. Fresher water from below rises to take its place. Over time, these slow-turning cells press the salt above them into the famous polygons that crack the flat into honeycombs. The hexagons you see when you walk across the flat are the quiet signature of water moving in the dark beneath you. Permafrost works in its own slow way. In the high Arctic, the ground freezes and thaws each year, but only in the top layer. Below that lies a deeper zone that never warms. Water trapped in the soil expands as it freezes, then shrinks as it thaws. Over many cycles, this gentle pumping sorts stones and fine soil into rings and stripes. The surface shows neat circles of pebbles around centers of mud. The cause is buried in the freeze line, the place where ice meets unfrozen earth, where the year's slow breathing happens out of sight. Even sailing stones may owe their motion to a hidden layer. On Racetrack Playa, the mud surface looks dry and cracked for most of the year. But after rare winter rains, a thin sheet of water can cover the playa. Cold nights freeze the top of that water into a delicate pane of ice. Beneath the ice, the mud stays soft. When a light wind nudges the ice sheet, it slides, and the stones frozen into it slide with it, leaving long tracks in the soft mud below. The trails on top are real. The mechanism is in the layer no one usually sees. There is a pattern to all of these patterns. The thing you can see is almost never the thing that is shaping it. The fairy circle is a window onto buried water. The salt polygon is the lid on a slow underground churn. The Arctic stone ring is the surface of an annual ice cycle. The sailing stone is a passenger on a thin, frozen raft. In each case, the rule seems to be the same. Look at the ground. Then imagine looking through it. Whether the deep cause is roots reaching for water, or termites tunneling toward a queen, or brine sinking through salt, the question remains open. We can measure what lies below. We cannot always tell which buried process began the pattern, and which one only follows along. The depths still hold their secrets, slowly, patiently, beneath every quiet design on the surface. Far in the north, where the ground stays frozen for most of the year, the land draws its own quiet shapes. From above, parts of the Arctic tundra look stitched together by some unseen hand. Pale lines crack across the soil in neat rings and squares and stars. These are called patterned ground, and they form across vast stretches of Siberia, Alaska, Canada, and the Scandinavian North. The shapes can be small enough to step over, or wide enough to fill a schoolyard, and they breathe slowly with the seasons. The rhythm that builds them is the rhythm of freeze and thaw. In late autumn, the soil cools. Water trapped in the ground turns to ice, and ice takes up a little more space than liquid water. The ground swells. Tiny cracks open across the surface, the way mud cracks when it dries. Only here it is cold that does the splitting. The cracks fill with hoarfrost and meltwater, which freeze again and grow into thin wedges of ice. Year after year, the same cracks deepen along the same lines. Over centuries, those lines settle into rough polygons, often with 5 or 6 sides, edged by low ridges or shallow troughs. The pattern feels almost designed. Walk across a frozen meadow in summer when the surface ice has melted and the tundra is soft and damp, and you can sometimes trace the outlines with your eye. A hexagon here, a rough square there, stones gathered at the edges, mosses and tiny flowers crowding the rims where the soil drains a little better. In the middles, the ground is often finer, sometimes dotted with cotton grass or pale lichen. The colors are gentle. Soft greens, rust browns, the silver gray of dried stalks, the faint blue shadow inside a melt pool. What still surprises researchers is how regular the spacing tends to be. In many places, the polygons are roughly the same size across whole valleys. One theory connects this to the depth of the seasonal thaw layer, the thin skin of soil that softens each summer above the deep permafrost. Where that layer is thinner, the polygons tend to be smaller. Where it is thicker, they grow wider. The ice wedges seem to find a comfortable distance from one another, like guests at a long table, leaving room on every side. Another theory leans more on the slow churning of the soil itself, called cryoturbation, in which freezing pushes stones and fine grains in different directions and sorts them over many winters into the rings and stripes we see. Both ideas hold real weight. Both leave gaps. Why do some areas form clean hexagons, while others form tangled mazes of polygons that never quite close? Why do certain slopes break the pattern into long, elongated cells, while flat ground prefers tidy circles? The math of how cracks share space is well understood in dry mud and cooling lava. In frozen soil, the same math seems to apply, only stretched across centuries instead of minutes. The cycle is just so slow that no single human lifetime sees a full polygon born. There is something steadying about that pace. A fairy circle in the Namib may shift over decades. A sailing stone may move once in many years. But an ice wedge polygon can take 1,000 winters to mature, then keep refining itself for thousands more. It is geology that pulses on the timescale of empires. The ground inhales each autumn, exhales each spring, and over deep time it carves a quilt across the top of the world. Climate change has begun to disturb this rhythm. As permafrost warms, ice wedges melt unevenly. The polygon edges, where ice has gathered for centuries, sink first, while the centers stay higher. Lakes form in the low rings. From above, the patterns become more visible than ever, even as they begin to come apart. Researchers track these changes from satellites, watching the slow unraveling of a design they have not finished reading. What seemed permanent turns out to be the result of an exact balance, one that has held for thousands of years and may not hold for many more. This is the strange tenderness of the cycles that shape patterned ground. They are patient. They are old. depend on the cold returning at the right time, in the right depth, for the right length of weeks. And within those conditions, the land somehow chooses geometry over chaos. No one tells the soil to draw a hexagon. It simply does, given enough winters. Why this happens at all, with such quiet precision, remains one of the open questions waiting under the snow. High on a lonely mountainside, far above the trees, the ground itself can be combed into stripes. Long lines of stones run down the slope, side by side, like the teeth of some quiet giant's comb. Between the stone lines, ribbons of finer soil rest in their own neat rows. Walk across them, and your boots cross stone, then soil, then stone, then soil again. No one laid them out. No one tends them. Yet there they are, patient on the cold hills, drawn into shapes that look almost designed. These are called stone stripes, and they belong to a wider family of shapes known as patterned ground. Their cousins are the frozen polygons of the Arctic we wondered about earlier, and the sorted circles we will visit later in the tundra. Stripes are what those circles and polygons become when the ground tilts. On flat land, the stones gather into rings and loops. On a slope, gravity pulls those rings apart and stretches them downhill into long, lined rows. The pattern is the same family, just leaning sideways. You can find stone stripes in many quiet, cold places. They appear on the high fells of Scotland, on the slopes of Iceland, on the bare ridges of the Rockies, on the mountains of Svalbard, and the cold corners of the Andes. They tend to live where winters freeze deep and summers thaw the top few inches of soil. Above the tree line, where wind keeps the ground bare, the stripes are easiest to see. From a distance, they can look like raked gravel paths, oddly tidy on an otherwise wild hill. The leading idea about how they form is gentle and slow. Each winter, water in the soil turns to ice and lifts the stones a tiny bit upward. Each spring, the ice melts and the stones settle back down, but not quite where they were. Over many, many cycles of freezing and thawing, the larger stones drift to the surface and then begin to sort themselves. Smaller grains slip into the gaps. Larger ones gather with other large ones. Add the gentle pull of gravity on a slope, and the gathered stones stretch into lines that run downhill. That is one theory, and it has good evidence behind it. Researchers have watched stripes form in lab boxes filled with wet soil and stone, cooled and warmed again and again. Over months, the stones inside really do sort themselves into rough lines. Still, the lab is not the mountain. Out on a real slope, the wind, the rain, the roots of small alpine plants, and the slow creep of the soil all play their part. How much of the pattern is freezing? How much is gravity? And how much is something else? Is still a question researchers turn over in their notebooks. What makes the stripes feel like neighbors to fairy circles and sailing stones is the rhythm. The spacing between stripes is often surprisingly even. On one slope, you might find lines about a hand's width apart. On another, the bands might be the width of a path. The size seems to depend on the depth of the freezing layer and the size of the stones, but the regularity is striking. The earth, given cold and time and a tilted surface, seems to prefer evenly spaced lines, just as it seems to prefer evenly spaced dots in the Namib sand. There are competing ideas about why the spacing is so regular. Some researchers think the size of the freezing cells in the soil sets the rhythm, like cells of slow convection beneath the surface. Others think the stones themselves push each other into place, jostling slowly until they find a stable arrangement. A third idea blends both, suggesting that the soil moves in slow rolls beneath, while the stones float on top and settle into the gaps. None of these ideas is fully proven. The mountain keeps its method to itself. Stone stripes also touch our story in another way. They remind us that patterns on Earth often share a deeper family resemblance. The polygons in the permafrost, the stripes on the fells, the rings in the desert grass. Each one is the same kind of quiet mystery in a different coat. They all hint that, given enough time and the right gentle forces, plain materials will arrange themselves into something orderly. Why this happens so often, in so many places, with so many different ingredients, remains one of the open questions running through this long night. For now, picture the cold mountainside under a low sun. The stripes lie in their patient rows, lined up without a maker, waiting through one more slow winter to be combed a little more finely. Some of the strangest patterns on Earth form in the places where life finds it hardest to hold on. The salt flats of the world are among those places. They stretch flat and white and silent under a hot sky, with crust so bright it can hurt the eyes. And across that crust, in many of these basins, the salt has arranged itself into shapes that look almost designed. Honeycombs, rings, long curving ridges, and in a few places, slow spirals that drift across the ground like frozen weather. Death Valley in California holds one of the most famous of these salt landscapes. The floor of the basin sits well below sea level in one of the hottest places ever measured on Earth. Air temperatures here have reached around 56 degrees Celsius, which is about 134 degrees Fahrenheit. The ground itself can grow hotter still. In summer, the salt crust bakes under a sun that feels heavy on the skin, and the air shimmers above it like slow water. Across the surface of this basin, the salt forms ridged polygons. Each shape is roughly the size of a small room, with raised white walls and a sunken pale center. From above, the pattern looks almost like a giant tile floor laid down by no one. The shapes repeat for kilometers. They are remarkably even in size, even though no hand shaped them. For a long time, researchers wondered why these salt polygons came out so regular. One older idea was that the crust simply cracked as it dried, the way mud cracks in a puddle. Another was that the salt grew outward from many tiny starting points until the growing ridges met their neighbors. Both ideas felt close, but neither quite explained why the shapes stayed about the same size across a whole basin, or why the ridges kept building higher year after year. A newer theory looks beneath the crust, into the wet, salty layers in the ground. Below the white surface, the soil holds briny water. The hot sun pulls fresh water up and out, leaving more salt behind at the top. As that happens, dense salty water near the surface sinks back down, and lighter water rises to replace it. This creates slow loops of moving water in the ground, turning over and over quietly for years. Where two loops meet and push upward together, salt piles up at the surface. That, the theory theory suggests, is where the ridges form. The size of the loops below sets the size of the shapes above. It is a calm and elegant idea. Yet, not every salt flat looks the same. Some show neat hexagons. Some show stretched ovals. And in certain rare basins, the ridges curl into slow spirals, as if the underground water moved in a turning motion instead of straight loops. No one is fully sure why a spiral forms here and a honeycomb forms there. The same physics should be at work, but the ground gives different answers in different places. The extremes of these flats stretch the imagination. The Salar de Uyuni in Bolivia is the largest salt flat in the world, covering more than 10,000 square kilometers high in the Andes. When a thin layer of rain spreads across it, the whole surface turns into a vast pale mirror that reflects the sky from horizon to horizon. As the water dries, the polygons reappear, etched into the salt like a quiet drawing. In Ethiopia's Danakil Depression, salt flats sit in one of the lowest, hottest places on the continent, with bright yellow sulfur ponds nearby and air that tastes of minerals. There, the crust forms its own slow patterns under temperatures that rarely cool, even at night. In the Atacama in Chile, ancient salt pans hold polygons that have been forming for many thousands of years in one of the driest deserts on Earth. Across all these places, the open question is similar. Why does the salt sort itself so neatly? Why do the same kinds of shapes appear in basins that are otherwise very different? The underground convection theory fits a lot of the evidence, but some researchers wonder if simple drying cracks, ground chemistry, and wind also play hidden roles that no one has fully measured yet. For tonight, picture the white floor of a great salt basin under a quiet sun. The air is still. The crust is warm. Beneath it, in the dark, wet salt, slow loops of brine turn over each other, year after year, drawing patterns on the surface that no one designed. The shapes are extreme in their regularity and extreme in their setting. And the reason they come out so even in such harsh places remains a question still drifting in the heat. In the quiet prairies of the Pacific Northwest, there is a stretch of land that looks from above like a great green quilt stitched with thousands of small, soft pillows. These are the Mima Mounds. They rise gently from the flat earth, each one round and low, sometimes only a foot high, sometimes as tall as a person. They sit close together in vast fields, spaced with a strange and quiet regularity, as if some patient hand had pressed them into the soil one by one. The most famous field lies in southern Washington state, on a flat plain not far from the small town of Little Rock. Walk among them on a misty morning, and the world feels almost dreamlike. The grass is pale gold. The mounds curve up beneath your feet like the slow swells of a frozen sea. There can be tens of thousands of them in a single field, and yet no one knows for certain how they came to be. The mounds appear in many places. They speckle parts of California, Oregon, and Texas. Similar bumps rise from the soils of Kenya, of South America, of parts of Asia. Each field has its own shape and spacing, but the puzzle is always the same. Why does the earth swell in such soft, repeating bubbles? Why here and not elsewhere? Why so even? One old idea blames the gophers. The pocket gopher, a small burrowing rodent, spends its life pushing soil upward as it digs. Some researchers wonder whether, over many generations, gophers slowly built each mound by carrying loose dirt toward a central high point, the way one might pile sand into a small hill while digging a hole. Computer models have shown that this kind of slow, patient mounding could, in theory, produce regular patterns over thousands of years. The spacing of the mounds in this view matches the size of a gopher's territory. But not every Mima mound field has gophers. Some lie in places where no such burrowing animal has ever lived. So another idea looks to the wind and the water. Perhaps during the last ice age, melting glaciers left silt and gravel scattered across the flat land. Perhaps the wind sorted that loose material into low dunes. Perhaps frozen ground beneath the surface cracked into polygons, and the soil above settled into soft humps where the cracks met. There are versions of this theory that involve floods, earthquakes, even the slow shrinking and swelling of clay as it dried and wetted again and again. None of these explanations satisfy everyone. The mounds in Washington sit on top of gravel that should be too coarse for gophers to easily move. The mounds in Kenya rise from soils that freeze and thaw in ways quite different from anything in North America. And yet the pattern, that soft polka dot field of low hills, appears again and again in places that share almost nothing else. Scientists who study these mounds often speak of them with a kind of quiet affection. They are not dramatic. They do not roar or glow or move. They simply sit in their slow geometry, waiting for someone to understand them. A researcher walking the field at dawn might notice how the light pools in the small hollows between the mounds, how the shadows stretch long and even, how the spacing feels almost musical. There is something restful about a pattern that nobody has solved. The small details matter here. Inside a single mound, the soil layers are often slightly different from the soil between mounds. The grasses that grow on the tops can differ from the grasses in the gaps. Tiny insects, beetles, and worms sometimes prefer one zone over the other. Each mound is a little world with its own moisture, its own warmth, its own quiet community of living things. Multiply that by 10,000 mounds in a single field, and you begin to sense the scale of the gentle mystery. There is a soft thought that some researchers hold close. Perhaps no single cause builds every Mima mound field. Perhaps gophers shape some, and frost shapes others, and wind shapes still others. And the reason all of them look so similar is that the earth, when nudged by enough small forces, simply tends toward this shape, a soft bump evenly spaced from its neighbors, a pattern that emerges wherever the conditions allow. That idea remains an open one. No final answer has been written. For now, the mounds rest under their pale grass, holding their secret in the slow curve of the land. And somewhere out there, in a field nobody has yet mapped, more of them are forming, one quiet grain of soil at a time. Walk across a dry lakebed in late summer, and you will see them. Tiles, plates of cracked earth, fit together like the floor of some forgotten hall. Many of them have 6 sides, or close to it. Others have 5. Some have 7. But the pattern repeats again and again across miles of sun-baked clay in deserts on every continent. The mud has dried into hexagons, and the question of why it does this took a surprisingly long time to answer. For most of human history, no one wrote about cracked mud as a puzzle. It was simply the ground. Farmers saw it in their dry fields. Travelers crossed it in dry seasons. The shapes were so common that no one thought to ask why they were shapes at all. The first careful drawings of mud cracks appear in the notebooks of 19th century geologists. Men who walked the dry beds of English rivers and the Playas of the American West with sketchbooks and small brass rulers. They drew the cracks as honestly as they could. They measured the angles, and they began to notice something strange. The cracks met each other at angles close to 120 degrees. 3 cracks meeting at a point, splitting the ground into 3 equal wedges. When enough of these triple junctions formed near each other, the shapes between them came out as rough hexagons. The geologists wrote this down with quiet care. They did not yet know why 120 was the magic number, but they could see that the earth seemed to prefer it. The first serious explanation came from a man who was not studying mud at all. He was studying soap. In the late 1800s, a Belgian physicist named Joseph Plateau spent years dipping wire frames into soapy water and watching the films that stretched between them. He noticed that wherever 3 soap films met, they always met at 120 degrees. Never any other angle. Soap, it turned out, was lazy. It wanted to use as little surface as possible, and the geometry of 120 was the cheapest way to share a junction between 3 sheets. Plateau's rules, as they came to be called, did not seem to have anything to do with deserts, but other scientists began to wonder. If a soap film wanted to minimize its surface, perhaps a layer of drying mud wanted to minimize something too. The mud was shrinking as it lost water. The shrinking pulled at the surface, and the cracks that formed were the surface's way of releasing that pull with the least possible effort. The idea was elegant. It explained why the cracks met at the angles they did. It explained why hexagons appeared so often, but it did not explain everything. Real mud cracks are messier than soap films. They form in stages, not all at once. The first cracks tend to be long and straight, splitting the ground into large plates. Only later do smaller cracks appear, breaking those plates into the tiles we recognize. And the first cracks often meet each other at 90 degrees, not 120. The pattern only settles into hexagons after many rounds of drying and redrying. This was the puzzle that 20th century researchers inherited. They built shallow trays in their laboratories. They filled them with slurries of clay and water. They watched the surfaces dry under lamps, photographing them every few minutes. They learned that the depth of the mud mattered. So did the speed of drying. So did the kind of clay. Thick layers cracked differently than thin ones. Slow drying gave different patterns than fast. One question that researchers still wonder about is whether mud cracks ever truly reach a final state, or whether they simply keep refining their pattern with each wet season. Some experiments suggest that a mud surface dried and rewetted many times will slowly approach a perfect honeycomb. Others suggest that perfection is never reached, that the pattern is always a compromise between competing forces. The matter has not been fully settled. The answer may depend on what kind of mud you start with. What the long history of this study shows is something gentler. The pattern in the cracked earth, the same pattern in soap films, the same 120 angle, the same restless tendency toward hexagons, the same quiet rule, written in mud and in foam and in honeycomb wax and in the cells of a young leaf. The discovery of mud cracks was, in a way, the discovery that the world repeats itself, that it uses the same few solutions in many different rooms. Why it does this at the deepest level is still an open question. The earth simply offers the pattern again and again and waits for us to notice. For many years, the fairy circles of Namibia stood alone in the world's imagination. They were thought to be a strange gift of that one quiet desert, unique to the red sand of southern Africa. Then, in the second decade of this century, something unexpected happened. A researcher studying patterns in arid lands noticed images from the Australian outback that looked oddly familiar. Pale, bare rings, evenly spaced across the dry red earth, ringed by tough golden grass. They sat thousands of miles from Namibia, in a different hemisphere, in a different ecosystem. Yet they wore the same quiet geometry. The grass that frames them is called Spinifex. It is a hardy, spiky plant that grows in low mounds across much of inland Australia. It clings to life in places where almost nothing else can. The bare patches it surrounds are wide, round, and strangely regular, just like their African cousins. Seen from a small plain, they spread across the land in a soft polka dot pattern, the gaps between them nearly equal in size, as if drawn by a careful hand. The discovery surprised many people. It suggested that fairy circles were not a quirk of one place, but a wider pattern that nature can produce in different deserts, with different plants, different soils, and different animals. That single fact reshaped the whole conversation. If two deserts on opposite sides of the world can grow the same shapes, then whatever causes them may be more universal than anyone guessed. Yet, the Australian rings carried their own surprise. When researchers dug into the bare patches, they found something different from what some had expected. The soil inside the circles was unusually hard. A thin, sealed crust had formed near the surface. Rainwater could not soak in easily. Instead, it flowed off the bare patch and pooled at the edges, where the Spinifex grew thick and green. In this version of the story, the circles act like small natural dishes, gathering scarce water and feeding it to the ring of grass around them. This finding pushed one theory forward. It is sometimes called the self-organization idea. In dry lands, plants compete fiercely for water. If a small bare patch forms by chance, water runs off it toward the nearest plants. Those plants grow stronger. Their roots reach inward, drinking from the bare patch and keeping it bare. Over time, the math of competition and runoff settles into a pattern of evenly spaced circles. No designer, no single cause, just simple rules repeated across a wide, flat plain. The other leading theory points instead to insects. In Namibia, sand termites had long been blamed for the bare patches. They eat young grass roots, the idea goes, and clear small round zones around their nests. Some researchers wondered if similar insects might be at work in Australia. Harvester termites do live in the Outback, and they do build hidden nests. Yet, in the Australian rings, the evidence for termite damage was thinner. The soil crust seemed to be doing most of the work. That has not settled the argument. It has only widened it. Some scientists now think both ideas may be partly right in different places. Perhaps termites set the stage in one desert, while soil crusts and plant competition shape the pattern in another. Perhaps the same final shape can be reached by more than one path. If that is true, then the fairy circle is less a single mystery and more a family of mysteries, each with its own quiet story. There is something gentle about that thought. The land is not following one rule. It is finding the same shape through different means, like rivers that all run downhill, but never trace the same line. The Outback rings, with their pale centers and golden borders, are a reminder that pattern can rise out of many kinds of struggle. Water moving, roots reaching, insects nibbling, crusts forming in the heat. The circle is the answer that emerges when the math of scarcity is solved. Standing among them at dawn, the desert looks almost still. The Spinifex moves only when a small wind passes through. The bare patches hold the cool of the night a little longer than the surrounding ground. Birds skim low over them, hunting for seeds caught at the edges. The light turns the red soil a deeper red, and the rings glow faintly, like soft footprints left by something the land itself is doing. We still cannot say with certainty which theory holds the larger share of the truth. Both have careful research behind them. Both have gaps. The Australian discovery did not close the question. It opened it wider by showing that the same quiet pattern can arise in places no one thought to look. On a cold, slow river in the far north, something strange begins to happen as winter deepens. Round disks of ice form on the surface, each one rimmed with a soft white lip. They look like pale pancakes, drifting and turning, gently bumping against one another in the dark water. Some are no bigger than a dinner plate. Others grow as wide as a small table. They spin slowly as they move downstream, and from above they look almost arranged, as if a quiet hand laid them out on the water. These shapes are called ice pancakes, and they form in only a narrow set of conditions. The water must be near freezing, but still moving. The air must be cold enough to chill the surface, but the current must keep the ice from locking into one solid sheet. As tiny flakes of slush gather and bump together, they round each other off, like pebbles tumbling in a stream. Each disk pushes against its neighbors, and the edges curl upward into raised rims from the constant, gentle collisions. What makes the ice pancakes feel related to the other patterns we have been wondering about is the way they appear without a plan. No one carves them. No one spaces them. They sort themselves into nearly equal sizes, drifting in loose clusters that look almost organized. It is the same quiet idea we saw in the fairy circles of the Namib, in the sorted stones of cold mountainsides, in the salt polygons of Death Valley. A system moves on its own toward order, and we are left to wonder why. This is the part of the story where the patterns begin to speak to each other. The ice pancakes, the sailing stones, the rings of grass, the columns of basalt, they live in different climates and different materials. Yet they share a kind of family resemblance. Each one is a place where a slow, steady force has met a yielding surface, and shape has emerged from that meeting. The sun pulls water into the sky, and the wind carries it across continents. The wind shapes dunes, and the dunes shape themselves into ripples. The cold freezes the river, and the river spins the ice into disks. Scientists who study these systems sometimes use the phrase self-organization. It is a careful phrase. It does not say the patterns are designed. It only says that, under certain conditions, simple rules between neighboring parts can lead to surprising regularity. A flake of slush does not know it is making a pancake. A blade of grass does not know it is part of a ring. Yet the rules of pushing and pulling, of growing and dying, of freezing and thawing, lead the whole system toward a shape. One theory is that these patterns are all driven by competition for something, for water, for warmth, for space, for energy. In the grasslands, plants may compete for moisture. On the river, ice disks may compete for the slush around them. In the salt flats, dry crust may compete compete for the salty water below. Each unit takes what it can, and what is left behind becomes the boundary between neighbors. The pattern is the map of that quiet competition. A different idea looks instead at the role of flow. Water flowing under ice, air flowing over sand, heat flowing through rock. These movements can set up gentle waves of pressure or temperature, and those waves can leave their fingerprint on whatever they touch. Under this view, the patterns are not the result of competition between living or solid things. They are the echoes of something moving smoothly past them. Both ideas may be true at once, in different places, and the line between them is not yet clearly drawn. What ties the ice pancakes to the sailing stones and the fairy circles is the listener's slow realization that Earth is rarely as chaotic as it first appears. The same planet that throws hurricanes and earthquakes also lays out hexagons on drying mud and spaces, grass tufts at even intervals across the desert. Order and disorder live side by side, woven into the same systems. The wind that destroys a sand castle is the wind that builds a ripple field a mile away. We still do not know how deep the connections go. We do not know whether one theory will someday explain all of these shapes, or whether each will keep its own private answer. For now, the river runs on under its starlight, the disks of ice turning slowly in the dark, bumping each other softly into nearly equal rounds. Somewhere a grass ring breathes in the Namib night. Somewhere a stone waits to be moved. The patterns keep their secrets, and the planet keeps making them. In the far north, where the ground stays frozen most of the year, the tundra holds another quiet pattern. Among the moss and lichen, the stones do something strange. They gather themselves into shapes. Some form rings. Some form polygons with stones along the edges and finer soil in the middle. From the air, the tundra looks tiled, as if a slow hand sorted the rocks by size and laid them out in a careful design. These are called sorted circles, and they belong to a wider family known as patterned ground. They appear in cold places all around the world, across parts of Alaska, Siberia, Svalbard, and the high Arctic islands of Canada. The stones along the rim can be the size of a fist, sometimes larger. The soil at the center is fine and pale, almost like sifted flour. Looking at them, you would swear someone had been at work, kneeling on the cold ground, separating coarse from fine. But no one has been there. The land does this on its own. And the more researchers look at how, the slower and stranger the answer becomes. The leading idea is that the freezing and thawing of water moves the stones very gradually over many years. When water in the ground freezes, it expands. When it thaws, it shrinks. Each cycle nudges the soil and the rocks within it. A stone may shift a fraction of an inch in a season. Over decades, those tiny shifts add up. Fine particles move one way. Coarse particles move another. The ground slowly sorts itself, the way a jar of mixed sand and pebbles might, if you shook it gently for 100 years. That is the favored theory, but the details remain open. Some researchers think the key force is the way ice lenses form beneath the surface, lifting stones upward. Others wonder whether convection plays a role, soft, slow circulations in the soil itself, almost like a thick liquid that turns over once every few centuries. Both ideas have careful support. Neither fully explains every pattern. The cold ground keeps part of its secret. What makes the sorted circles especially interesting is how slow they are. A fairy circle in the Namib may shift across years. A sailing stone may move in a single wet night. But a sorted circle in the tundra changes across human lifetimes. The rings you see today were arranged, in part, by frosts that happened before your grandparents were born. To watch a sorted circle move, you would have to sit beside it for centuries, sipping something warm and wait. That makes them gentle reminders that the earth is always changing, even when it looks completely still. The tundra seems frozen and quiet, but beneath the surface, ice is breathing. Water is freezing in the night and softening in the day. The stones are moving in increments so small that no eye can catch them. The ground is alive with slow work, and right now, that work is changing. The Arctic is warming faster than most of the planet. The permafrost, the soil that has stayed frozen for thousands of years, is beginning to thaw in places. When it thaws, the freezing and thawing rhythm shifts. The seasons that built these patterns are no longer the same seasons. Some sorted circles may slow down. Others may speed up in surprising ways. A few may blur entirely, their tidy borders softening as the ground sags and slumps. Researchers are watching, but no one knows yet what the long-term picture will look like. The patterns took thousands of years to form. They could change in only a few centuries, perhaps less. What we see on the tundra today may be a kind of snapshot, a moment from a slow story whose next chapter is being written by a warming sky. Some scientists wonder whether sorted circles will become rarer over time, drifting into memory like footprints in soft snow. Others think new patterns may emerge as the climate shifts, shaped by different cycles than the ones that came before. Both ideas remain open. The tundra is too vast, and the timescales are too long for anyone to be sure. For tonight, it is enough to picture them. Wide, flat plains under a low gray sky, patches of moss and pale lichen, stones laid out in rings as if by careful, invisible hands, a wind that smells of cold stone and old ice, the quiet knowledge that somewhere beneath the surface, the ground is still sorting itself, one slow freeze at a time, the way it has for longer than anyone can remember. The mystery of why nature insists on order, even here, drifts along with the cold wind and waits patiently for an answer. There is a soft idea that has followed us through every chapter so far, walking just behind the patterns like a quiet companion. It is the idea of self-organization. The word is long, but the meaning is simple. Things sometimes arrange themselves without anyone arranging them. No hand, no plan, no blueprint. Just small parts following small rules, and a pattern rising up from the doing. To picture it, imagine the light on a desert at dawn. The sun is low and golden, and it slides across the sand at a shallow angle. Where the sand is flat, the light is flat too, a smooth wash of pale honey. But where the wind has worked the surface, the light catches every tiny ridge. Each ripple casts a thin blue shadow on its windward side. The desert glows in soft bands of gold and shadow, repeating outward until the eye gives up counting. No one drew those bands. The wind did not know it was drawing. And yet the pattern is there, lit by the early sun as clearly as if a careful hand had combed the sand. This is the whispered idea. Patterns can rise from rules that have no goal. Grains of sand do not plan to make ripples. Termites do not plan to make rings. Water does not plan to crack into hexagons as it dries. Each tiny actor follows its own small habit, and from the sum of those habits, a shape appears. Researchers who study self-organization look for the rules first. In the fairy circle hypothesis that involves plants, the rule might be simple. A young grass plant near another grass plant competes for water. The stronger one drinks more. The weaker one fades. Over time, the surviving plants space themselves apart, and from above, that spacing reads as a field of pale circles ringed by green. The pattern is not the goal. The pattern is the leftover shape of thirsty roots. In the sailing stones, the rules are different. Wet mud, thin ice, a soft wind, a stone that happens to sit just so. Each variable is small. Together, they produce a long curving track that looks almost deliberate. Light helps us see these tracks best when the sun is low. At noon, the Playa is a flat white glare, and the trails almost vanish. At dawn or dusk, the same trails throw long shadows into their own grooves, and the whole dry lake bed reads like a page of pale handwriting. There is a second view, of course, and it deserves its place beside the first. Some researchers wonder whether self-organization is the whole story or only part of it. Maybe in some places, the ground itself has hidden structure we have not yet measured. Old root systems below the surface, pockets of clay arranged by ancient floods, mineral veins that guide where water lingers. If that is true, then the pattern we see in the light is not pure self-organization. It is half pattern from below, half pattern from above. Both ideas remain open. Neither has been ruled out. Light is the way we test these ideas. From the ground, a fairy circle is just a patch of bare earth. From a low plain at golden hour, it becomes one note in a vast repeating song. From a satellite, with the sun angled just right, the song stretches across kilometers. The pattern only reveals itself at certain distances and certain hours, when light and shadow agree to show us what flat noon hides. The same is true of the salt polygons. At midday they are blinding white, almost featureless. But when the sun drops low, every crack in the salt grows a thin, dark line, and the whole basin lifts into a honeycomb of bright tiles and dark seams. Researchers photograph these places at sunrise and sunset for that reason. The angle of light is the angle of understanding. This is part of why the question of self-organization remains so hard to settle. The patterns prefer to hide. They show themselves only in slanting light, only from certain heights, only after the rain, only when the season is right. We are still learning when to look, and from where, and with what kind of camera. Each new vantage adds a few more pieces to the puzzle, and a few more questions. For tonight, it is enough to picture the long golden light moving across the desert, lifting the soft ripples into view, drawing the faint rings out of the grass, tracing the quiet trails of stones that have not moved in years. The light shows us the pattern. The pattern hints at a rule. The rule, for now, stays mostly whispered. If you stood at the edge of a fairy circle in the Namib desert and closed your eyes, you would hear almost nothing at first. The desert is one of the quietest places on Earth. Then, slowly, the small sounds would come. The dry rasp of wind moving across stiff grass. A faint hiss as sand grains slide down the side of a low dune. The soft click of a beetle crossing baked earth. And under all of it, if you could somehow listen through the ground itself, there would be another sound, too quiet for human ears. The sound of termites at work. Sand termites live in the soil beneath much of the Namib. They are pale, small, and almost never seen above ground. They tunnel through the sand in long networks, chewing the roots of grasses, moving moisture, shifting tiny grains from one place to another. If you pressed a sensitive microphone against the dirt, you might pick up the faint scratch of their jaws and the soft shuffle of their bodies. It is a whispered sound, almost like rain falling on paper somewhere far away, and it sits at the center of one of the longest arguments in modern desert science. For many years, One group of researchers has wondered if these termites are the quiet builders of the fairy circles. The idea is gentle and patient. The termites eat the roots of grass in a small patch. The grass dies. Without grass to drink it, rainwater soaks deeper into the bare soil and gathers below. The termites thrive on that buried water. The bare patch becomes a kind of reservoir, a hidden well that helps the colony survive the dry months. Over years, the pattern spreads, and neighboring colonies push against each other until the circles space themselves out across the plain. Another group of researchers listens to a different sound. They hear the wind. They hear the rustle of grass blades brushing against each other. And they wonder if the plants themselves are doing the patterning, with no insect required. In their view, grasses compete for the same scarce water. A patch that gets a little less water dies off. The surviving grasses around it pull moisture toward themselves, drying the bare spot further and keeping it bare. The plants self-organize, like quiet neighbors who agree, without speaking, on how far apart to stand. For more than a decade, these two ideas have moved back and forth like a slow tide. Field studies in Namibia have found termite nests under many circles, which seems to support the insect theory. Other studies, especially in Australia, have found fairy circles with no termite activity at all, which seems to support the plant theory. Some researchers now wonder if both ideas may be partly right, working together in ways the math has not yet fully described. The argument is long, but it is not loud. It is carried out in careful papers, in quiet field notebooks, in the soft tap of boots crossing the desert at dawn. The sounds of the desert do not take sides. The wind keeps moving in long, even breaths across the plain. It carries the dry smell of warm sand and old grass. It bends the stems of the surviving tufts so they hiss faintly together, a sound like distant surf heard from far inland. At night, when the air cools, the grains of sand contract and sometimes give off the faintest ticking, almost too soft to notice. The termites keep working below, indifferent to the human disagreement above them. Other patterned landscapes have their own quiet voices. On Racetrack, Playa, when the thin sheet of ice cracks at dawn, it can release a long, low sigh, a sound that seems to come from everywhere at once. Basalt columns sometimes ring softly when struck, each pillar a slightly different note. Salt polygons in Death Valley pop and tick as the crust expands in the heat. A faint chorus across miles of flat white ground. Patterned ground in the Arctic groans when the soil freezes and thaws. The sound traveling under the snow like a slow heartbeat. None of these sounds answer the central question. They are simply the world going about its work while we try to listen. Why does nature settle into rings and stripes and polygons instead of pure chaos? The wind does not say. The termites do not say. The grasses bend and lift and bend again, keeping their secrets folded into the soil. For tonight, it may be enough to imagine that desert at dusk, the light turning soft and orange, the circles spread out like quiet thoughts, and under everything, the faint, patient sound of a question still being asked. Most people know one place where stones move on their own. That place is Racetrack, Playa in Death Valley, where the flat clay floor of an old lake bed holds long, shallow trails behind quiet rocks. But the Playa is not alone. There are other dry lakes in other deserts where stones seem to slide across the ground without any hand to push them. And once you start to look for the simple math behind that movement, something gentle and surprising appears. In northern Nevada, a place called Bonnie Claire Playa holds its own set of moving stones. The trails are softer, fainter, sometimes almost erased by wind. In parts of Mongolia, in dry pans high on the Tibetan plateau, travelers have reported stones with shallow grooves trailing behind them. The pattern of these places is the same. A flat clay floor, a rare thin sheet of water, a cold night, a light wind, stones that wait, then move, then wait again for years. The math behind the sliding turned out to be far simpler than anyone first guessed. For decades, people imagined strong winds, hurricane winds, lifting and shoving boulders across the desert. The numbers did not work. To slide a stone that heavy across dry clay, the wind would need to be impossibly strong. The arithmetic refused. So the mystery sat, patient, for nearly a century. Then then a small group of researchers measured what actually happens on those rare, wet winter mornings. The answer arrived in a quiet equation. A thin sheet of water, only a few centimeters deep, freezes overnight into a fragile pane of ice. In the morning sun, the ice cracks into wide floating panels. A light breeze, only 3 or 4 meters per second, pushes those panels across the shallow water. The ice presses gently against the stones. The stones slide. The numbers behind this are almost humble. A breeze you could barely feel on your face. A film of water thinner than your finger. An ice sheet only a few millimeters thick. Together, they move rocks that weigh as much as a small child, sometimes a small adult. The forces add, multiply, and balance in a way that feels designed, though no one designed it. This is part of why mathematicians find the moving stones so calming to think about. The equation is small. The result is large. A whisper of wind becomes a journey of many meters. The ratio of cause to effect feels like a kind of magic, except it is not magic. It is just the quiet arithmetic of friction, buoyancy, and pressure, written across a lake bed in trails of mud. These simple ratios show up in many corners of Earth's patterns. The angle at which sand grains come to rest on a dune slope is almost always around 34 degrees. No matter the desert. The spacing of ripples in shallow water follows a clean relationship to the speed of the current above. The cracks in drying mud meet, more often than not, at angles close to 120 degrees. Because that angle releases the most stress with the least effort. The Earth seems to prefer the cheapest solution. Nature, in this sense, is thrifty. Still, the math does not explain everything. At Racetrack, Playa, researchers have watched stones move and recorded the conditions. The basic mechanism is now understood. But why do some stones travel in straight lines while their neighbors curve gently to the side? Why do two stones, sitting only a meter apart, sometimes head in different directions on the same morning? The equations describe the average behavior. The individual stones still keep their secrets, and the question grows wider. If such a small force can move such a heavy stone, what other patterns on Earth are written by forces so faint we have not yet measured them. A breath of warm air rising from the soil. A trickle of water moving through sand. A vibration from a distant storm. Each one too small to notice alone. Each one possibly the quiet author of a shape we already see, but do not yet understand. This is the part of the mystery that mathematicians love most. The rules are simple. The outcomes are not. A handful of numbers repeated across millions of grains or stones or cracks produce the gentle order we find written on deserts and tundras and dry lake floors. The universe seems to run on rules a child could learn, and yet those same rules, applied long enough in the right places, draw patterns that still leave grown scientists standing quietly in the wind, hats in hand, wondering how something so plain can become something so strange. The math is beautiful. The math is incomplete. Both things, somehow, are true at once. Some patterns on Earth only reveal themselves from very high up. From the ground, they hide in plain sight. A person walking through them sees only grass, or stones, or cracked mud, or a gentle slope of sand. The order is too large to notice at human scale. Only when you climb into a small plane or look down from a satellite does the hidden geometry appear. The fairy circles of the Namib are like this. Standing among them, you see scattered bare patches. From 1,000 feet up, you see a vast field of dots, evenly spaced, stretching to the horizon in soft red and gold. The grass tufts form a kind of honeycomb across the dry plain. The order is real. It was simply too big for our eyes to catch. This raises a quiet thought. How many patterns on Earth have we missed, simply because we were standing too close? For most of human history, we walked the ground at eye level. We saw what was near. The sky above the ground was empty of cameras. The whole planet's surface, in its full geometric strangeness, was invisible to us. Only in the last 100 years or so have we begun to look down from above. And every time we do, we find new shapes we did not know were there. This is part of what makes the patterns so fragile to think about. They depend on conditions that hold steady across enormous spaces. The Namib's red dots need a certain rainfall, a certain soil, a certain grass, a certain warmth, all balanced together over many square miles. Change one, and the pattern softens. Change two, and it may vanish. The dots are not painted on. They are the visible edge of a long, quiet agreement among many small things. The same is true of the salt polygons in Death Valley. They form because water rises through the salt, dries at the surface, and cracks in a slow rhythm. If the water table dropped too far, the polygons would freeze in place and slowly crumble. If it rose too high, they would dissolve back into a flat white sheet. The shapes live in a narrow band between too wet and too dry. They are a record of balance, held for now. Earth itself sits inside a similar kind of balance. The planet circles the sun at a distance that allows water to exist as liquid, ice, and vapor all at once. A little closer, and the oceans would boil away. A little farther, and they would freeze solid. The thin shell of air around us, only a few dozen miles deep, keeps the surface warm enough for grass to grow and stones to slide. That shell is so thin that, if the earth were the size of an apple, the atmosphere would be no thicker than the skin. Inside that thin layer, all of these patterns play out. The fairy circles, the sailing stones, the basalt columns, the polygons of the tundra. Each one needs its own narrow set of conditions. The sailing stones need a desert that floods just enough, freezes just enough, and dries just enough, each in the right order. The basalt columns need lava that cools at a steady rate, neither too fast nor too slow. The frost polygons need ground that freezes and thaws year after year in the same gentle cycle. Shift the temperature a few degrees, and many of these patterns would stop forming. Some would slowly fade. Others would never have appeared at all. There is something quietly humbling in this. The geometry written across our planet is not guaranteed. It depends on a long list of small mercies, each one holding its place. The right gases in the air, the right tilt of the axis, the right tides, the right slow rain, and it depends on time. 2 long stretches of steady conditions, allowing the patterns to settle into themselves. Researchers who study these systems often speak of them as living at the edge of stability. Push too hard and the order collapses. Leave them alone, and they breathe slowly, year after year, holding their shape. We do not know exactly how close to that edge each pattern sits. Some may be more resilient than they look. Others may be more delicate than we suspect. For now, the patterns remain. The red dots still hold their spacing under the Namib sky. The stones still drift across the dry lake bed. The polygons still crack the salt in slow hexagons. From above, the planet looks decorated with a quiet design we did not draw and do not fully understand. From below, we walk through it, mostly without noticing, while the long balance continues to hold. Long before any scientist measured a fairy circle or tracked a sailing stone, people who lived near these places had their own quiet stories. The patterns were already there, written in the dust and the grass, waiting to be noticed. And the people who noticed them did what humans have always done. They told tales. They gave the patterns names. They tried to make sense of shapes that seemed to have no maker. In the Namib, the Himba people speak of the fairy circles as the footprints of their original god, Mukuru. Each bare red ring is said to be where the god once stepped, leaving the soil scorched and bare. Some stories speak of a great underground dragon whose breath rises through the sand, killing the grass in perfect circles. Other tales describe the circles as the work of spirits who dance in the desert at night, wearing the ground smooth with their feet by dawn. These stories are old. They were told long before satellite cameras ever looked down from above. In the deserts of the American West, the indigenous peoples who lived near the dry lake beds had their own ideas about the sliding stones. Some traditions describe the rocks as living things that move when the world is empty of watchers. Others speak of the stones as messengers, leaving trails to mark the passing of something unseen. The trails were proof that the desert was never truly still, even when it looked frozen in place. In Ireland and Scotland, the basalt columns of the coast were said to be the work of giants. The stepping stones at the Giant's Causeway were thought to be the ruins of a path one giant built to cross the sea. The hexagons were too regular to be natural. They had to be made by hands, or by something larger than hands. The folklore did not explain the geometry. It honored the strangeness of it. Across Scandinavia and Siberia, the patterned ground of the cold tundra inspired its own quiet legends. The polygons in the soil were sometimes seen as the breath of sleeping spirits beneath the earth. The frost circles were the cooking pits of beings who lived under the ice. Mima mounds in different parts of the world were said to be the work of giant gophers, or ancient burial sites, or the resting places of beings no one remembered anymore. These stories were not wrong in the way we sometimes think old stories are wrong. They were attempts to hold the mystery. They were ways of saying that the land does things we cannot yet explain, and that the doing must mean something. The science we have now is younger than most of these tales. The folklore has been sitting with the question for far, far longer. What the old stories share with modern research is a quiet humility. Both admit that something is happening on the ground that we did not cause. Both admit that the patterns came from somewhere we cannot fully see. The scientific theories about termites and grass competition and convection rolls in cold soil are newer answers to the same ancient observation. The shapes are real. The makers are hidden. There is something gentle about realizing this. The fairy circle that puzzles a researcher today is the same fairy circle that puzzled a herder 1,000 years ago. The sliding stone that no one has ever watched move was already moving in the time of the old desert dwellers. The hexagons cooled into stone long before any human I saw them. We are not the first to wonder. We are only the most recent. Some researchers now wonder whether the folklore itself holds clues worth listening to. The careful descriptions in old stories often record the exact places where patterns appear most strongly. They sometimes describe the timing of when circles grow or shrink. They sometimes note conditions like wind direction or rainfall that line up with what modern instruments are beginning to measure. The stories were a kind of long, patient observation. The conclusions were poetic. The watching was real. Other researchers are more cautious. They worry that reading the old tales as data risks bending them into shapes they were never meant to hold. The folklore was about meaning, not measurement. Mixing the two too freely could mislead both. What remains open is whether the very urge to find patterns in both science and story points to something deeper. Maybe the human mind and the patterned earth share a kinship neither fully understands. Maybe the circles and the trails appear regular to us because we are shaped to notice them. Maybe they would appear regular even without us. That question, too, remains unanswered. For most of human history, we could only see Earth's patterns from the ground. A traveler might walk into a circle of bare soil in the desert and notice it. A shepherd might cross a field of stone stripes on a mountainside and feel the strangeness of them under their boots. But no one could see the full design. No one could rise above the land and watch the dots, the rings, the polygons spread out across the surface like quiet writing in a language no one had learned to read. That changed in the last few decades. Satellites now circle the planet at all hours, taking soft, patient photographs of the ground below. Some look in visible light, the kind our eyes can see. Others look in infrared, sensing the warmth of soil and plants. Still others use radar that can peer through clouds and even through thin layers of dry sand. Together, they have begun to reveal something the groundwalkers never quite grasped. That Earth is covered in patterns we had barely counted. The Namibian fairy circles were one of the first big surprises from the air. Seen from above, the red dots stretch in long bands across hundreds of miles. The Australian rings, found only recently, showed up in satellite images before anyone fully mapped them on the ground. Patterned ground in the Arctic, once known only to a handful of polar researchers, now appears in vast, lacy networks across the tundra. Salt polygons in dry lake beds, sorted stone circles on cold plateaus, faint rings in old farmland. All of it shows up when the camera floats high enough. What the satellites are starting to reveal is not just where these patterns sit, but how they change over time. A circle that looked permanent from the ground may, in fact, drift slowly. New rings open, old ones close. The bare dots in the Namib breathe in and out across decades, growing during droughts, shrinking when the rains return. Some researchers wonder if the patterns are alive in a way we did not expect, not living things themselves, but slow, breathing arrangements of soil and water and root. Other patterns only become visible because the satellite sees colors our eyes cannot. Healthy plants reflect a certain shade of infrared light. Stressed plants reflect another. By mapping these subtle differences, researchers have found faint rings and stripes in places that look perfectly even from the ground. The earth, it seems, is patterned in ways we walked over for centuries without ever noticing. No one is sure how many patterns are still hiding. One idea is that we have already found most of the big ones, the fairy circles, the stone stripes, the polygons. Another view is that we are only at the beginning. As satellite cameras grow sharper and the years of data stretch longer, fainter and slower patterns may emerge. Patterns that take a century to complete a single cycle. Patterns hidden beneath grass or shallow water. Patterns we cannot yet imagine because we have not built the eyes to see them. The question of what these patterns mean has also shifted. With ground observations alone, each mystery felt separate. The rings in one desert, the stones in one valley, the polygons in one frozen plain. From orbit, they begin to feel like cousins. Some researchers wonder if a single deep principle of self-organization runs through all of them, expressed differently in different soils and climates. Others are not so sure. They point out that the math behind each pattern still seems distinct, and that lumping them together might hide the real story. Looking far ahead, the satellite record will keep growing. A child born today might, late in life, scroll through 100 years of images of the same patch of desert. They might watch a fairy circle open like a slow flower over 40 years, then close again. They might see a salt polygon split, fuse, and split again across a century of wet and dry. The patterns that once seemed frozen will reveal themselves as slow-living things, breathing on a timescale longer than any single human life. And beyond that, in deeper futures, the satellites themselves will be gone, replaced by something else, or by nothing at all. The continents will drift. The deserts will move. New patterns will form on coasts that do not yet exist, in soils that have not yet been laid down. whatever rules Earth follows when it draws these quiet shapes, those rules will keep drawing. The designs will keep appearing, whether or not anyone is watching from above. For now, we are simply lucky enough to have started to look. And so we come to the wide view, the slow stepping back, the moment where we let the whole picture settle into focus. We have spent hours together among rings of grass and trails of stone, among frozen polygons and salt hexagons, among mounds and ripples and columns of dark rock. And the strange thing, the quiet thing, is that none of these patterns truly stands alone. They are part of something larger. They are part of a planet that seems to want, again and again, to arrange itself into shapes. Step back further. Earth itself is a pattern. It is a sphere because gravity pulled its matter inward, and a sphere is the simplest, most efficient shape that can hold so much weight. The continents drift in slow curling arcs because the heat inside the planet moves in great looping cells. The oceans pulse with tides because the moon, our quiet companion, tugs at the water in a steady rhythm. Every layer of this world, from the iron core to the thinnest wisp of cloud, is shaped by forces that prefer order to chaos. Step back further still. The atoms that build the sailing stones, the silica in the sand, the carbon in the desert grass, the iron in the red soil of the Namib. None of these were born on Earth. They were forged inside ancient stars that lived and died long before our planet existed. When those stars collapsed, they scattered their elements across the dark, and some of that scattered matter, billions of years later, gathered itself into the rocky world beneath your feet. The calcium in your bones, the iron in your blood, the oxygen filling your lungs as you breathe slowly now. All of it was once inside a star. So when you look at a fairy circle in the desert, you are looking at something built from stardust, arranging itself into a ring. When you watch a sailing stone leave its long, quiet trail, you are watching stardust slide across stardust. The patterns are not separate from us. We are made of the same materials, shaped by the same rules, drawn toward the same strange tendency to find form in the formless. This may be the deepest open question of all. Why does the universe favor pattern at every scale we can measure. Galaxies spiral, hurricanes spiral, seashells spiral. The bones of a fern leaf branch in the same fractal way as a river system seen from above. Honeycombs and basalt columns share the same six-sided geometry. Sand ripples on a beach echo, the cloud ripples high above them. Some thinkers believe this is simply because a few basic forces, gravity, surface tension, diffusion, growth, keep producing the same answers wherever they appear. Others wonder if there is something deeper, some quiet mathematical preference woven into the fabric of reality itself. A preference we have not yet learned to read. We do not know which view is closer to the truth. We may never know. The patterns we have named so far, the circles, the polygons, the spirals, the stripes, are only the ones obvious enough to catch our eyes. There are surely others, slower or stranger or larger, that we have not yet noticed. Patterns that unfold over thousands of years. Patterns that span entire continents and only show themselves to satellites looking down from far above. Patterns hidden in the deep sea, on the floors of trenches no light has ever reached. The earth is still writing, and most of its handwriting remains unread. There is something gentle in that thought. The world does not need us to understand it. The fairy circles will keep appearing and fading in the red sand, whether anyone watches or not. The stones will keep tracing their long, quiet trails across the dry lake bed. The frozen ground will keep sorting its pebbles into rings. The salt will keep cracking into hexagons under the desert sun. These are not puzzles set out for us to solve. They are simply what the planet does in its slow, patient way while we go about our small, bright lives. And yet, we are part of it too. The same forces that shape the circles also shape the patterns of our breath, the rhythm of our heartbeat, the branching of the blood vessels behind our eyes. We are not separate observers standing outside the mystery. We are the mystery, looking back at itself. We are stardust wondering why stardust likes to form rings. We are patterns trying, with quiet curiosity, to understand other patterns. For tonight, that is enough. The questions will still be here in the morning, waiting, patient, unhurried, beautifully unresolved. And so we come to the quiet end of our long, slow walk across the patterned skin of the earth. We have stood in red deserts and watched circles of bare ground rest among the grass. We have followed the slow trails of stones across a dry lake bed in California. Stones that move when no one is looking. We have crouched at the edges of salt flats, traced the cracked hexagons in drying mud, and looked down from imagined heights at the soft bumps of Mima mounds rolling across green prairies. We have wondered at columns of basalt rising like dark organ pipes by the sea. None of it has been fully solved. That is the strange and lovely thing about this whole long story. The patterns are real. The patterns are everywhere. The patterns are stitched into sand and ice and grass and stone. And still, after all our careful watching, the earth keeps a little of the answer to itself. Some researchers lean toward the idea that life makes the shapes. Termites under the desert. Roots that drink in patient rings. Small creatures sorting the soil grain by grain over centuries. Others lean toward the idea that the shapes need no life at all. That water, wind, frost, and gravity, given enough time, will arrange themselves into circles and stripes and polygons, all on their own. Both ideas hold pieces of truth. Neither one holds all of it. And the gentle argument between them goes on, quiet as the desert wind. Maybe in your lifetime, someone will settle one of these questions. A new satellite will spot a clue. A young scientist will notice something that everyone else has walked past. A drone will hover above a fairy circle at dawn, and finally catch the moment it begins to form. Or maybe none of that will happen. Maybe these mysteries will stay open for a long, long time, the way some mysteries do. The earth is in no hurry to explain itself. For now, picture the planet from a soft, imagined distance. A blue and white sphere turning slowly in the dark. On its night side, the desert's cool. Sand shifts a few grains at a time. A stone on a dry lake bed sits perfectly still, waiting for the next rare rain. In the far north, the tundra freezes a little deeper, and the slow rings of sorted stones settle further into their quiet geometry. Off a cold coastline, thin pancakes of ice spin gently against each other on a slow river, their soft edges curling upward. None of it is loud. none of it is in a rush. The patterns are simply being made, one breath of weather at a time. On the day side, light moves across grasslands speckled with pale circles. Wind combs dunes into long parallel ripples that look, from above, like the grain of polished wood. A salt flat in Death Valley dries 1 more millimeter, and the hexagons there grow a little more crisp at their edges. Somewhere over the Atlantic, a column of basalt that cooled long ago still stands in its 6-sided shape, washed by the same tide that washed it yesterday and the day before that. You are very small in this picture. So am I. The patterns are old, and they will keep being made long after this night is finished. There is something restful in that. The earth does not need us to understand it in order to keep arranging itself into circles and stripes and gentle, ordered fields. It will go on shaping the ground, slowly, patiently, whether we are watching or not. Let the questions rest now. Let the termites rest under their warm sand. Let the stones rest on the cracked clay. Let the polygons of the Arctic rest under their thin blanket of frost. Let the Mima mounds rest beneath their soft grass. Let the basalt columns rest by the sea. Let the desert circles rest in their wide red quiet. Let yourself rest too. You do not need to solve anything tonight. The mystery will still be here tomorrow, and the night after that, patient as ever. The earth keeps its quiet designs, and we get to wonder about them, and that wondering is enough. It has always been enough. We may understand these patterns one day. We may not. For tonight, it is enough to know they are out there, drawing themselves slowly across the world while you drift off, safe and small inside a vast and gentle place. Subscribe for a brand new Earth topic every night. One tap, and something wonderful is waiting for you tomorrow. Sweet dreams.